Right. Just waiting for YouTube to say I'm live. Hey, okay. Hello. So, if you've read the title, I'm gonna try and speed code a VM. I've written a VM before, didn't go well, and I actually need to write a VM for a project that I'm gonna do. So I thought, why not try and speed code it? Since I've already done it before, I kind of got the grasp of things, and I'm probably gonna fail miserably, but there we go. Let's do this. So, if you hate that I'm using the Python idle IDE, then I mean you're right. Other than that, everything looks fine. So, what do we need? I don't know what imports I'm going to need. First of all, let's define our memory, because our memory is going to be just read from this file here. There we go. Memory equals open. Actually, I'm going to have to put that in brackets. Open memory.txt in read mode, and then we'll do dot read. There we go. Lovely. We're going to want to split that actually, aren't we? Yeah, because it's going to be basically we're going to have the binary in each line. So let's just split that. Split by new line. Okay. Okay, so we've got our memory loaded. Then what else we're going to need? Well, let's make all of our registers and stuff. So what do we need? We need the PC. Okay. We need my reconnected. Okay, lovely. My OBS disconnected. Don't know what you missed. Anyway, what was I doing? So making the registers. So we need a PC. We need a CIR. How am I doing in caps? CIR. We need a. What else? Accumulator. Sorry, it's my computer science. I'm used to doing it in all caps. We need a. MAR. This is really just testing my computer science skills right here. You know what? Because to make it look nice, I'm gonna actually do it in caps. So we've got a PC, CIR, MAR, MDR. If you don't know what any of these are, you didn't take computer science. What's the other one? MDR, MAR, CIR, PC, accumulator. Yep. And that's it. Question mark. Question mark. That's it. Alright. Yeah, that's it. Yeah, that'll be it. I'll figure out later if it's not. So, PC gives the stuff to the MAR, so we'll just take in the address, which in this case will be the line of the text file. MDR will just get the. I don't want to put instruction. That's too computer sciencey. Oh yeah, why not? Okay, instruction. Instruction. Accumulator will get the. I'll just put code. CIR will get the. Get stuff, because it's the stuff it needs to get, whatever. Yeah, okay, so let's start the PC. Let's start with 1, because always good, because we're going to start at the top, aren't we? So but it's done in 0, so we'll do 0. Okay, so first thing we do is we do MAR, and we give it the address. There we go. In fact, just to make sure it's, because otherwise it's going to really annoy me, I'm just going to put that there so it's all in order. Oh, where's my mouse? It's gone to my second screen. Okay, that's going to give it to the PC. PC's now got the address. Not PC. MAR's now got the address. So the MAR's going to grab that from memory. So it's going to be instruction is equal to memory address. Okay, and then it's going to give that to the MDR. I could just do this as all one line, but it looks cooler, it looks more professional if I put them all in functions. MDR, we'll just give instruction. Okay, so now MDR's got the instruction. MDR then passes that to the accumulator. There's literally no point of the MDR really. I'll keep it in there anyway, yeah, because the CIR will pass the stuff to the, and I'll keep it in, I'll keep it in. Shut up. Accumulators, so the accumulators got that. Oh, we also need to pass it to the CIR. See, I know it would be useful. CIR instruction. Actually, no, I only need to do that if it's got something else we need to fetch. So say if you're saying move whatever's in address 3 to address 4, it's CIR's then got to get whatever's in address 3 so that you can then put it in address 4. Okay, oh, this isn't going to be much for speed code, is it? ACC accumulator. So once the accumulator's got the code, we then need to pass all of our code to the ALU. Okay, so literally again, no point of the accumulator. And then once it's done that, actually, yes there is, because we can do some algorithmic things here. We can pass all of that to the MDR again, which is what happens. That's not going to be very useful for us, is it? I'm actually just gonna, I need to go back to the PC, don't I, after that. So we'll do PC false, and just do PC stars, then that brings it back to the beginning, and then the whole thing runs again. Lovely. Then CIR gets whatever's from the MDR. So we are in the MDR, we're actually going to need to run a check whether anything is needed to be fetched by the CIR, and then if it is, then we send it to the CIR. So what we need to do is, I'm just going to make it so if it's something that has a hashtag, that means you need to run and get it. Normally in a regular instruction set, a hashtag means an actual number, so you do move hashtag 7 to register 3, which means move the number 7. But this case I'm going to do, when a hashtag 7, it means register 7 or memory address, whatever 7. So it will do for I in instruction, if I is equal to a hashtag, then CIR instruction, and then we'll, yeah, perfect, which means we can get rid of this. Lovely. Right, but that means we can't send it to the accumulator yet, because we need to wait for whatever our stuff is. Okay. How we can do that? Let's I could make a separate function so that the CIR then passes whatever it is to the separate function, which then passes everything to the ALU. Well, first of all, let's make it so if there isn't a hashtag, we don't have to worry about any of that. But then, if there is, we shall wait for that. Ooh, right. This is weird. Unless I just make it so you can't do stuff with other registers. But you kind of need that, really. So the CIR doesn't really get explained in computer science. Like, if you look at a diagram of a CPU, it kind of like, it sends stuff to the CIR, and then that goes back round in a loop, but it doesn't actually explain it at all, so I'm not entirely sure what to do here. Let's... Oh, this is awful. This is not speed coding at all. This is so slow. I don't know what to do. Okay, right. We'll worry about that later. Okay, so we've passed the instruction to the accumulator. The accumulator sends it to the ALU. Okay, let's worry about the ALU. Can't spell. ALU. What do you code? Okay, so if this is where it all gets into, actually we'll do code equals code dot split by, oh, it's going to be in binary, isn't it? Oh, it's all going to be in binary. See, in my last VM I made it so it was all in binary, and then it had to decode it back into instructions, which means I needed to make a separate assembler. So basically I wrote like move 1 to 3, the assembler made turn that into binary, then the VM read the binary and turned it into move whatever 3, which was pointless then. So I'm not going to make it in binary actually. So we'll just do code.split by space. Okay, so now if we do if code 0 is equal to move, then so the second operand will be whatever it's moving to, and the first one will be the number. Okay, so and then if in the code it's rather than number it's a register, the CIR would have already fetched that. We'll worry about that in a sec, but the CIR would fetch that and re-put that number in the code. Don't know how I'm going to do that, but we'll do that at the moment. So, in a moment. So, if it's move, then memory. Actually, no. Oh, so I'm going to have 2 registers. Normally there's thousands or millions, but I'm going to have 2. So, if, not memory, if code 0 on 2 is equal to 1. Actually, I should do that, shouldn't I? Actually, no, because it will be in a string. Is equal to 1. Then R1 is equal to code 1. Lovely. And if we just, copy and paste this, just change these to 2, then that's that. And then at the beginning here, let's do R1 is equal to 0 and R2 is equal to 0. There we go. Lovely, and there's our 2 registers done. So that's the move command. What other commands do we need? Subtract. Yeah, subtract. Add. Adding. Right, I'm going to have to do add actually first. Tell you what, to make my life so much easier, if we just, it's not cheating, it's just working with what you got. We don't need the code, but cause that's already done. But if code 0 equals add, if code then R1 equals code1 minus code equals R1 plus code 1. Lovely. Do the same here. One thing I have, just a mistake I've noticed, you probably noticed before me, is that this needs to be registered 2. There we go. Lovely. Everything coolio, looks like it. So we've got 2 instructions so far. Wow. So at the moment our instruction set is composed of 1 bit. You know what? I'm gonna add more later, but for now I'm gonna leave it as that. So we've got 2 instructions, and then obviously whatever's here needs to be put over to the accumulator again. So if we do ACC, No, we're not, because whatever it's done won't. We don't need an output from the accumulator. Have I done anything about that? No. So that's all fine. So once this is run, then this will go over here and do whatever. Cool. CIR, right. So now all we need to do is the CIR, and then we've got a VM, hopefully. Fingers crossed. Well, not a VM, a CPU, virtual CPU. Okay. CIR. So, if something has a hashtag, send it over to the CIR. So we need to decode whatever has a hashtag. So let's do code equals get stuff dot split by a space. Okay, so now our thing would be like move hashtag 7 2 for like register 2. So the hashtag's always going to be in the second place, because the registers, you've either got register 1 or register 2. But so the hashtag's always going to be, by the way, everything's always going to be saved to the last operand. So code 1, it's always going to be code 1. Why did I just write that? I don't know what I'm doing with it yet. So we need to fetch it. So if code 1 is equal to hashtag 1, then operand is equal to R1. Yeah. Yeah, that's right, yeah. Yeah, that's right. Sure it is. So then, oh, what have I just done? So then, if it's 2, it's equal to register 2. So if it says, oh, whatever's in register 1 to register 2, you do add hashtag 1 2. So it'll take. So then the first operand is going to equal register 1. So say register 1 you have number 3. It's going to then add the number 3 to register 2, and then say 2 in register 2 is the number 1. You're going to have 4 now in register 2. Yeah, it's pretty lit. Okay, that's that then. So now if we just if we return the operand, and where have I done that here? So if we do operand is equal to that, so that's then going to return that. Right, so we need to now, so we have a string, yes, that says move hashtag 1 to 2, okay? We need to, so this is all one string. We need to rip out the hashtag 2, whatever I just said, hashtag 2, and replace it with the operand that we've just returned here. So what we're going to do is we're going to split it by space, but then we're going to need to join it back together. Can I do that? So if I let's split it, take it out, replace it, and then join it back together. I'm pretty sure I can do that. So let's do instruction equals instruction. Oh no. Instruction dot split. Yeah! Coming! Oh my goodness. Okay, give me a sec. Guess who's got sandwiches? Oh my god, that happened on stream. Okay, where was I? Oh, I should probably close my door. Right, where was I? Okay, splitting it, ripping it out, whatever. So, we split it. So now, you know, I can't be bothered. We're just gonna, I'm gonna call this code. So, code 1 is now gonna be equal to operand. Cool. And now, if we do code equals code.join, join code. Yeah. Let me just check this out. If we do a equals, no, how, and then are you? Oh. Can I not do a question mark? Okay, guess not. Oh, what's happened here? Don't know what's happened there. A equals. Sorry, guys. How are you? Yeah. Okay. Cool. Don't know why it was coming black. Right. So A equals how are you? So if we do A equals A dot join A. A equals A dot join A dot join A join A. Okay. Code equals code dot join A. Okay, if we do code as a string, and then we do code dot join A, so we're joining. Okay, cool. So code is now equal to really. Okay, code equals code dot join A. So code is now equal to how are you with no space. Okay, we're getting there. Well, alright, forget the join function. The join function is stupid because it doesn't add the spaces back in. So we're just going to make our own. So if we do for, let's just make code a string again. So if we do for I in code, not code, for I in A, code equals I plus space code. Okay, we're getting there. We're so close. Right. So close. Just the one thing. Okay, for I. Oh, let's put code back to a regular string. Okay, for let's just make sure A is still okay. For I in A, so it's going to do each thing. So it's going to be how, then R, then you. Code equals. Oh, that's where I went wrong. Okay, code plus I plus space. The only problem with this is that it's going to work, but we're going to have an extra space on the end. But I don't think that will matter. Hopefully it won't matter. Oh, it might though. Okay, we can easily fix this though. But all we need to do is, where's the accumulator? We need to do if code2 equals 1 with a space. Okay, so now we've got it. So now if we do code equals operand, well, let's just make sure I didn't. Okay, I didn't mess that up there. Okay, code1 equals operand, and then if we do for I in code A equals A plus code plus a space, and then let's just define A as our little string that we're working with. So now we need to do ACC A, and then that's going to pass our new thing where we've gotten the number out of the register and it's now sending that over to the ACC. But now we've added the spaces, that works fine with that. But if we didn't have to rip it all out and put it back together, like we do here, then it's not going to have that space on the end. Oh, this is going to be so tacky. But it will work, okay? Look, if we just do or 1, so tacky, but it's fine. And we just do the same for that, and for that, but we just changed these to 2. There we go. Save. That should be all of it, right? What am I missing? I'm missing something, 100%. So, say for an example, we put move 1 to 1. So moving the number 1 into register 1, okay? It's going to read that. It's going to split it by each line. It's going to just have this. Then the PC. That's right. It's not going to run. So if we do PC, it's our final thing. I don't know, false, whatever. Doesn't matter what we put. Cool. So PC is going to start up here. PC is going to be equal to 0. We haven't incremented it. Okay, we're getting there. We need to define the PC up here equals -1, and then PC equals PC plus 1. Cool. So then the first time it runs, it will then run the PC plus 1, so it'll be 0. Then when the ALU is finished, it'll go back there, and it will next be 2. Cool. So we've got the number 0. Sends that to the MAR. So then it's doing instruction memory address 0. So that's the first thing, which will be this. And then it sends this to here as instruction, where it then passes it to the accumulator. The accumulator then passes this to the ALU, where it splits it by space. Code 0 will be equal to move, code 2 will be equal to 1, this one, so then register 1 will be equal to code 1. Oh, okay, it's going to be as a string, so it's not going to be able to do that. Actually, yeah, it won't matter, because it will just be set as a string 1. But that's going to mess up our addition. Right, that's fine, it's fine. So equals int code 1, boom, fixed. We just need to do this for each one. So code 2. Okay, and now especially for our addition, otherwise it will 100% not work because it will be reading as a string. Okay, so now that's reading it as the number 1. So it will register 1 be equal to the number 1. Yeah. And then I'll tell you what, at the end, oh, okay, once it's run out, it's going to try and, hold on, I haven't actually made the ALU go back to the PC yet. PC equals, PC, false. Where have I made that? Because I made it do that before. So I've obviously done that in the wrong place somewhere. PC false, accumulator. Ah, yeah, because I thought that I'd have to send it back, but I don't. Okay, cool. But now it's going to come up with an error, because it's going to try and increment by 1. It's going to be like, oh, what's memory 2? There isn't a memory 2, and it's going to kick up an error. So, it's going to be out of range. We need to check and make sure it won't be out of range. We'll do that in the PC. So, PC plus 1. Try. Memory PC. Yeah. Try memory PC. And we'll just pass and accept. Sorry. End, and we'll make a separate function. Oh, I know that's gonna annoy me. It's really gonna annoy me that I have a function that's not meant to be there. But we'll just call this def end, and it will literally just it will normally exit, okay, but for now we're just gonna print whatever's in register 1, just so we know that's working. And then we're just gonna pause. But normally it would exit. But it's just so we can see if the number 1 is in register 1, then we know it's all working. Right, let's see what errors I'm going to get up here, because it's definitely not going to work first time. Alright, there we go. PC equals PC plus 1. This all needs to be tabbed. Invalid syntax, memory. Oh, yeah, okay. Try. I don't know. I need to do something with memory PC, but I can't just do that. Oh, hold on. I've done that syntax entirely wrong, which I came up with syntax error. Try print. No, because I don't want it to actually print. Memory PC. Oh, shut up. Okay, then accept. Okay, no such no such file. This is still registered on my desktop. Okay. Hold on, because I just don't want to lose it, that's all. Do I still have it on my VM speed code? Move, replace, VM speed code. So is this now, if I save it, it's still saying it's in my desktop. Hold on, let's just get rid of that. Come on. Idle. 3.6. Okay. I'll just replace it quickly because the same code's there. So if you just do, I just want to overlay it so it's exactly the same. Cool. Get rid of this first one. And then we've got this, which is now in the right folder if we run it. Okay, local variable PC referred PC equals PC plus 1. Where is that done? Line 11. Please don't tell me it's here. Okay. I shouldn't need to make that global though. I really shouldn't. Okay. Fine. Well, at least that gives me something that I need to pass to PC. But then that means whenever I do it here, it's not going to work. Because these variables don't have PC to pass to it. I'll make it global. Shouldn't need to though, really shouldn't need to. But you know, and I'll tell you what, I can tell you now, global's not going to work. Yeah, there you go. Because for some reason Python's like, you know what? You know, you're trying to make a global variable. We're not going to let you do that. Because that'd be way too easy. Yeah, global variables are weird. Okay. Unless I pass the PC to every other thing. Which will be a huge pain. But you gotta do what you gotta do. Oh, this is gonna be so annoying because I was trying to make it exactly like a proper register. Like a proper CPU. I can't now. Address. Oh, what have I done there? PC. and then this passes that and the PC. I don't need to pass it there. Okay, that's sent to the ACC. Now it passes that. Then that receives that. Hold on, does the ACC receive it? No, it doesn't. It does now. And then it can here now pass back the PC. So it goes one big loop. Okay, instruction is not defined for iron. Instruction. That's because I was doing the PC and it went, oh no, oh no, oh no, 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 no. Oh no. Well then, that's the first. I'm actually so happy that's the first time, because you hear always people saying, oh, don't get in an infinite loop. That's the first time I've ever accidentally made an infinite loop. That's so weird. What's going on here? Right, let's stop it. In MAR ACC instruction PC. Where's the error? Oh, that's so annoying. Where's the... Where's the error? Right, line 36, blah, blah, blah. So there's obviously, what's happened is there's already obviously an error somewhere, but it keeps passing the error on. So each variable keeps getting the error, but it's not showing me the error. Python, I hate you. Stupid thing. Who uses idle as their IDE? What idiot would do that? So much for speed coding, by the way. Oh, that's so annoying. Oh. Maybe if it's at the... Must be something with the PC. Must be. Because it's like passing it on, unless it's the instruction. Sorry. What if I make a separate function that whatever it like that always returns the PC, and then no, yeah, no, I can't do that, because then whenever the PC increments, it won't increment. Unless we make it. You'll see what I mean. If we do define, I don't know why I said that so weirdly. Define. If you define, we'll just do count A and B. So if A equals 1, then PC is equal to B. So let's do PC equals -1. Oh, I can't. No, I can't. I was gonna make it so. I don't know what I was trying to think. Why can't the PC be passed to the stupid variable? Hold on. Right. Is it because it needs to be done after the variable, the function is defined? So now if we do PC, let's just print PC, and then we'll pause it. That was stupid, so I've got this named that. Oh, that would be the error! No, it wouldn't, because I had it passing the actual PC, that was... This is so stupid! Why? This shouldn't be happening! Why can't I pass a variable? It's defined, it's not like... Surely, if it's defined outside of the function, the function should be able to access the variable. No, that's what every other program I've made does. Why is Python suddenly not doing it now? It's so stupid, especially if I've made it a global variable, but still no. So stupid. Maybe they weren't called the same thing or something? Global PC. PC A. Print PC. Yeah, I've made it a global variable, so this is just Python not working. Okay, right. Okay, well that's annoying. So I've made it global, and it's still not picking it up, so that's not my end. Because it probably... I don't know. Python. Hate you sometimes. Why can't I go back to good old days of making batch scripts? Right. Right. I swear, I could have been done half an hour ago. It's just this one thing, it's so stupid. I mean, unless I don't use the PC as a function, if I put the entire thing in a while loop, and then that while loop is the PC, that's a big thing to do, and it'll be very difficult to get everything back. I'll tell you what, for now, what I'm going to do for now is I'm going to comment all of this out. Oh, come on, PC. That might have been the error, actually. I put a space there. Okay, what I'm going to do is I'm going to do while true. So this needs to be defined before this. And we'll do MAR. That's Mac. MAR. I don't know why I found that funny. The PC, and then I can get rid of this, or comment it out. And then once that's done all of that here, it will just end. So this will end, which means this will end, because this will pass all two of these other things that's done here, and then it will do it again. So I can actually do PC equals PC plus 1, which means I can actually set this as 0. See what it does. Please don't be an infinite loop. Okay. Instruction memory out of range. Yeah, I did a check for that up here, didn't I? Yeah. Let's try and accept. So let's try to accept it. So try memory PC accept end. No. I was like, yeah, outputted something, but no, it has to output 1. So it's outputting register. Oh, is it because it doesn't have access to global variables? Oh, I'm gonna have to make them a file, because whenever it's saying, you know, make register 1 0 or make register 1 1, that's only for this function, because as soon as it goes to a different function, register 1 is still 0. So I'm going to have to make this 100 times more inefficient with just 2 lines of code by making each of these its own file. So if we basically just copy this bit, okay, open r1.txt in append, because we want to be able to read and write to it. So it even sounds like proper register terminology. Yep, same thing here, but with R2, D2. And now down here, whenever I have R1 is equal to, R1 equals, right, so rather than that, we just do R1 dot write that. Yeah. So R2 dot write. Yeah. So where do I have that still? Here. I don't need to do that actually. I don't need to put another bracket there. Yeah. Okay. And same thing here, just that, and then can get rid of that. So now, if I try to print, I need to re-get it. Or no, I don't. I need to print r1 dot read. Dot write. Must be string. Oh, okay, that's gonna be odd. Actually, no, it's not. I just need to make sure. Oh, I'm gonna have to do that separately. Okay. So, if we do str, so we're gonna make it an integer while plussing it, and then it's all gonna be encased in a string. Correct. Okay, cool. This I can just take that out. Yeah. Ah, really? Not, wait, what? Oh, print not readable? What do you mean it's not readable? R1, what's in here? I need to put zeros in both of them at the beginning. R1 dot write 0. R1 dot, R2 dot write 0. So stupid. Let's try now. That might have been it. It probably wasn't. No, it wasn't. Not readable. How is it not readable? What do you mean it's not readable? How can a text file not be readable? Just read it, bro. Right. Oh, by the way, you didn't probably see that. It was on my second screen. Okay. I reckon when it's trying to read it, it might be deleting whatever's in there because it's coming up with an error. So it's reading it and then it's coming up with an error, but it's already tried to read it bit, so it's probably destroying it. So I'm just gonna add the pause. What I'm gonna do is okay. So I'm on the input bit. Oh, okay. Probably just ruined it again. Sorry. You'll see what I mean. So okay, it's now this bit. It's at the end. Try and read it. What's in here? Still nothing. So at some point, whatever's in it is getting deleted. Well, it's obviously the right bit down here. So when it's trying to write 1 into 1, move command. Okay, move code 2 equals equals 1. R1 dot write code 1. Okay. So this is the code it's trying to run. Forget all of these. It's trying to run this bit here. Ooh. So if we print code 1 just for our benefit, and then afterwards, let's just do that for now, just so we can see what it's trying to. Okay, so it is trying to put the number 1 in there as a string, I'm assuming, because it came up as blue. So for some reason, is it not doing that? Print r1.read. What happens there? Not readable. Okay. Let's do a little input just for a pause there. So it gets to there. Did it write the number 1 in? It didn't write it. I wonder if it's, do we have to define it as a string? Maybe. What? What? It's not writing it. R1.write. Bro. I mean, unless I have to open it each time, like, you'll see what I mean. So if I do something like R1 dot right, if I do like oh, this is so annoying. Oh, this is so annoying. It's just not writing to it. There's no reason why it shouldn't, but it's just not. It literally is like, right, and it's like, nah. This is so, how long has this stream been going on for? 52 minutes. Oh wow. This is not speed coding at all. Oh my goodness. Right. Why me? Oh, that's all I want to know. Just why me? Okay, so Python won't read global variables, won't write to files. Everything I try to do, it just won't do. It's like, oh, you know what'd be funny? This last bit that he's been working for like 50 minutes on. Everything he tries, let's just not do it. So stupid. So stupid. And I can't see that I'm doing anything wrong. Which probably means I'm doing something wrong, but that's not the point. Why isn't it writing? It's not even, if it came up with an error that it's not writing to it, fair enough. But it's moving along as if it's writing to it, and then it's just not. Yeah. Oh no. It's not. Oh, of course, because for some reason this file won't read global variables, or defined variables in that case. So up here, well, that's probably just where from my, hold on, R1 equals open R1.txt append, blah, whatever. I don't care anymore. R2, D2. Just the silent pain. Is it working yet? Oh my god. Out of all my time, I've been programming for a long time, okay? It's never been like this. Nothing has worked this bad. What is wrong? There's like no explanation, you know? I'm gonna have to change the title of this to worst programming ever. Yeah, okay, well I'm gonna finish this stream. For some reason it's not working. I don't think that's my fault. I think for some reason I'm gonna have to restart my computer because Python's not working. Yeah. I don't know why Python's not working. It's probably because it knew that I was gonna try and stream something. But seriously though, I don't know why. Don't know what's wrong with it or anything. But I'm gonna end it here. So, thank you for sorry, I can't say. Okay, thank you for watching. Like, subscribe if you enjoyed my pain. Then at least give it a like. Then I mean, thank you. I mean, yeah. Goodbye. End stream.